Hi students, welcome back. Let us start the next topic, a very important topic, the friction. So, the friction is a desirable property, at the same time it is also the undesirable property. So, desirable property in the sense, the very simple reason I can say, the reason I am standing here and the reason you are sitting there with comfort, okay, is nothing but due to friction only. If there is no friction between the contact surface, between my legs and the floor, I cannot stand here with comfort. Okay, at the same time you cannot sit there with comfort here, right? So friction is a desirable property. At the same time, more amount of friction leads to many number of undesirable problems or unnecessary problems. So therefore we have to keep the friction up to a certain level in order to get the desirable results here. So at the same time, therefore we can say that friction is a friend and also it is a foe. Friction is a friend and a foe, right? Therefore now I want to go over the discussion of the concept of friction here. So I will just give the introduction for friction, then I shall go for the applications of friction in the next coming classes. Okay, so as we know that friction is mainly due to the surface roughness. Okay, right? So due to the interlocking of the surfaces, due to the interlocking of the projections of the surface which are in contact, that is due to the friction here. Now for example, I am taking a surface upon which a block is resting here. So whatever the weight of the block may be, whatever type of the surface may be, and if you separate the surface and if you separate the block here, just see the contact, just observe the contact surface I am having. So this is the contact surface the surface is having, and if you observe in the microscopic level, okay, these are called as the surface irregularities. You can see something like these are called as the minute projections or the called as surface irregularities of the entire surface here. And if you observe the bottom surface of the block here, which is resting on the block, this block will be also having some surface irregularities here. These are surface called as irregularities, also these are called as the minute projections. Okay, so whenever this block is placed onto this surface here, so these irregularities are there. No, these irregularities will mesh with each other. Something like, for example, see, my hand is having the irregularities in this way here, and my hand is having the irregularities in this way here. So whenever if you put this hand into this hand, these irregularities will mesh into each other. These irregularities will come together and these irregularities will mesh into each other. Okay, so due to the meshing of these irregularities into each other, when certain amount of force is applied on this block here, okay, the body cannot move immediately due to the application of this force. But there is some certain limit of the force, okay, up to which we have to apply on the body such that the body can slide over. Okay, so what I want to say is friction is mainly due to the surface irregularities. The friction force always depends upon the surface irregularity that is present between the two contact surfaces. So more the surface roughness, more the friction value. Okay, frictional resistance here. Okay, now I want to discuss regarding the concept of the theory of the friction. Okay, so what is the minimum amount of force that is required to move a block? Okay, now I want to draw a graph that is present between frictional force and applied force here. I want to develop a graph that is present between the frictional force and the applied force here. So let me draw the graph here. Okay, so before that, let us take a block. Just listen to me carefully, it's very important concept. Let us take a block which is resting on the horizontal surface here and which is having some weight W. Now what I want to do is, I want to move this block due to the application of the force P here, right? Now, if you apply the force P, generally what happens? So generally what happens means, this reaction mainly depends upon the frictional force acting at the surface here and the value of the P that is acting on the block here, right? Now, so due to the application of the force P, the body cannot move immediately. Okay, So what will be happening is, whatever the force that we are applying on the block, that force should reach the limiting friction, or it should cross the limiting friction force that is developed at this contact surface, and if this value is greater than limiting friction force, then the body starts sliding here. That is the concept. What is meant by limiting friction? Limiting friction is the maximum frictional resistance the body or the surface can offer towards the body. Okay. Now every surface will be having its own limiting friction, or every surface will be having its own maximum frictional resistance. So if the surface offers maximum frictional resistance, so we have to apply more amount of force acting on the body to provide the sliding or to create the impending motion acting on the body here, right? Now see here, for example, I am just drawing the Freebody diagram of this block. Okay. Right. Now I am taking the weight of the block here. So don't discuss about the weight of the block here. I am just applying a force P on this block here, right? Okay. Now what I am saying is, the maximum frictional resistance this surface can offer. For example, I am saying this maximum frictional resistance this surface can offer is equal to some 10 newtons. I am saying, just listen to me carefully, you can understand everything very clearly. So I am taking the F maximum value is equal to 10 newtons. That is the value I am telling. Okay. That means this is the value it can offer. Okay. Now, for example, we are applying a force of P is equal to 2 newtons on this block. Now, what I want to do is, I want to slide this block. Not slide this block. First of all, I want to just provide the impending motion. So impending motion is nothing but which is opposite to pending. So pending motion is nothing but the body is at rest. The body is having no motion. The body is having the pending motion. So impending motion in the sense, no more the body is in rest. No more the motion of the body is impending here, right? Now I am taking a block here upon which I am applying a force P. Okay, I am applying a force P. Due to the force P, I need the impending motion here. Now, for example, if you are applying a force of 2 newtons, now due to the application of the 2 here, 2 newtons is less than 10 newtons. So therefore, due to the application of 2 newtons, the frictional force that will be developed will be equal to 2 newtons here. Okay, so whatever the force we are applying, the same amount of frictional force will be developed here at the contact surface, and the friction force will be always equal to 2 newtons only. Okay, so due to the application of the force P, the frictional force developed is equal to 2 newtons here. But the maximum friction it can offer, is nothing but 10. But now it is offering only 2. Now for example, if you increase this value 2 newtons to, for example, I am taking this one as some 8 newtons. Then if you are applying a force of 8 newtons here, then F will be also gradually increased to 8 newtons. Okay. So now what I am doing is, I am applying a force of 10 newtons. I am applying a force of some 10.2 newtons. Then the frictional force that the surface can develop is equal to only 10 newtons. So we have a difference of 0.2 newtons. Due to this 0.2 newtons difference here, the body starts moving in this direction. The body is just about to slide. Whenever this P is equal to 10 newtons, or it is reaching the value of F which is equal to 10 newtons here, then the body is having the body will be having something like just inertia force feeding to provide the inertia force here. Is just about to slide. That type of movement the body will be having, right? So this is the concept of friction. Okay. Now I will explain once again. I will go with this example. For example, if you draw the Freebody diagram for a block, generally what happens? So you will be generally drawing the normal reaction with the weight of the body, right? So due to the presence of this weight, normal reaction is developed here. Okay, this is the action, this is the reaction. In the same way, if you apply the external force acting on the body, an internal force will be developed, or the force will be developed inside the body. This is called as the reaction force. Okay, and I can say this reaction force is acting always along the surface of contact. Therefore, I can say this is called as the tangential resistance or the tangential reaction force. The tangential reaction force will be always acting in the opposite direction to the external force acting on the body, and this is called as the frictional force. Okay, are you following? Therefore, in order to create the movement inside this body, we have to apply the force such that this force should reach the maximum frictional resistance, and this maximum frictional resistance is called as the limiting friction. What is meant by limiting friction? So very important point. Limiting friction is the frictional force is the maximum frictional force any surface can provide. Limiting frictional force is the maximum frictional force any surface can provide. Okay, so this limiting friction value depends from surface to surface. The value will be always changing from surface to surface here. So one surface will be having some other maximum friction ratio and some other surface and some other maximum friction will be having, right? Okay, so actually in this case we have three types of friction. Something like a static friction. Not the types of frictions here. So we have some regions here. The static friction region, limiting friction is second, the third thing is nothing but kinetic friction region, right? Now see here. For example, the maximum limiting friction it can offer is nothing but 10. The maximum friction it can offer 10 here, right? So initially, if you are applying a force P of is equal to 0 newtons, I'm applying here. So you have reached a force of 10 newtons, and then we are applying a force which is nothing but always greater than 10 newtons, right? Okay. Now I will indicate the limiting friction value with a symbol of F. You can indicate with any symbol here, and I can say this one as F maximum. Okay, and this is called as limiting friction FL. Also I can say here, right? So initially I am applying a force of 0 newtons. So I am increasing from 0 to 1, 2, 3, 4, 4 up to 10 I am applying here, right? So, and here in this region also, if P is equal to 0, F will be also equal to 0 newtons here. So the range from 0 to below 10 newtons, that is nothing but, for example, 9.99 newtons I am saying, right? Which is less than 10 limiting region. The region that is present between the zero limit of frictional to the maximum frictional limit, this limit is called as the static friction range. Okay, so why it is called as static friction range? So therefore in this range the body will not move, the body will be at rest. But in this range the frictional force will be increased from 0 to the maximum frictional range. Okay, it's called as limiting friction. Okay, and next thing is the range that is present between the maximum limit to the body which is moving here. For example, the body is moving with some friction, with some external force. You know one thing, whenever the body is moving with some external force, in that motion also the body will be experiencing some friction. That friction is called as the kinetic friction. That is nothing but the friction that is experienced by the body when the body is in motion. Is in motion here. This is called as kinematic friction here, or kinetic friction. And this kinetic friction is always less than the limiting friction, because whatever the limit that is the surface is having, whatever the maximum friction resistance the surface can offer, we have crossed that maximum limit here. So after the crossing the maximum limit, the friction force cannot reduce. The friction force cannot be always greater than its limit here. So we have crossed that limit here. This is called the maximum limit here, right? Now I will explain the phenomena that is present with the help of a graph present between the external force and the frictional force. P is called as the external force we are applying on the body. F is called as the frictional resistance that is present between the block and surface. Okay. Now, so from 0, there's nothing but from 0 to limit. We have totally 3 number of regions here. So 0 to limiting frictional range I can say. And next thing is nothing but kinetic frictional range here. So kinetic frictional range. K, F, R I am saying here. So these are the limits here. So initially at the force P is equal to 0. If the value of force P is equal to 0, then F will be also 0 here. So these two values will be equal to 0. Okay. If you go on increase the value of P, then the F will be also increased up to some limit, up to certain region. As the value of P increases, P is nothing but external force acting on the body, F is nothing but frictional force getting on the body here, experienced by the body. Okay. As the value of P increases, the value of F will be increased here. P and F are proportional here. But after reaching the maximum limit of the frictional force, this is called the maximum limit of the frictional force here. Okay. With the increase of P, the frictional force always comes down. The frictional force at a time the frictional force comes down. Okay, so due to the increase of the external force, the frictional force comes down and then it remains constant in this way here. Okay, so this may be a curve, it can be of anything, nothing to worry about. So this region from 0 to A I am taking here. So this region from 0 to A, this total region is called as the static friction region. Okay, and this point A is called as the limiting friction, or also I can say this one as the maximum frictional resistance. Maximum friction. Okay, so after this point here, after crossing the point A, so this frictional force will be reduced at a time, and after reaching to the minimum limit, it remains constant here. And this total region is called as, this total region I can say this one as the kinetic frictional range, and the friction that is experienced by the body. So keep 2 points in your mind. The maximum amount of frictional resistance the surface can offer is called as limiting friction. Okay, the frictional force, the friction that is experienced by the body when the body is at rest is called as static friction. The friction that is experienced by the body when the body is in motion is called as kinetic friction. And the magnitude of the kinetic friction is always less than the magnitude of the kinetic friction is always less than the static friction. Okay, and the maximum frictional resistance the body can offer is called as limiting friction. Okay, one more important point is, for example, I am taking a body here. I am applying the force P on the body here. So due to the application of the friction, application of the force here, the F is developed here, and this becomes the normal reaction. This becomes a weight. All these things are common here. You can get that. For example, if there is no force P that is acting on the body here, so generally what happens, if there is no force P acting on the body here, then there is no frictional force acting on the body here. Since we can say as something like action and reaction. If there is no weight that is acting on this surface, there is no normal reaction produced by the surface on the body. Therefore, something like these two are equal and opposite to each other. Okay, so try to understand the concept here. If there is no force acting on the body, there is no friction force acting at the surface. If there is no weight acting on the body, there is no normal reaction acting on the body here. That's all. Okay, that is the thing. So we have some laws of friction here. So very important laws we have. The first law is nothing but frictional force. Frictional force is always dependent on the surface roughness or smoothness of the contact surface. And next thing is, second thing is, frictional force is independent of the area of contact. The amount of area of contact is independent. Okay, and next thing is, frictional force is always proportional to. Okay, I will just first of all note down these points. I will just draw the diagram once again for you. Okay. Right, now see here. For example, let us take a body. It's right here. So this is the marker. 1 minute. Okay. Right. I am taking a body here that is resting on the horizontal floor. Now, what becomes the free body diagram? This body is having some weight W here. So, what becomes the free body diagram here? If you draw the free body diagram, you can say that, okay, so weight of the body will be always act in the vertical downward direction, and this is called as action, and due to the reaction, normal reaction will be always acting in the upward direction here. And on this body, if you apply a force P here, okay, so the same amount of frictional force will be acting on the body up to the body is coming to the impending motion. So impending is nothing but opposite to pending. So for example, pending motion, that means the body is at rest. Impending motion, that is nothing but motion is impending. That means, therefore we can say that the body is starting to move. So whenever this P is greater than F, then the body starts moving here, right? And we have a small law which is called as the frictional, the first important law of the friction is nothing but Newton's laws of friction we have. The first law is nothing but whatever the frictional force that is developed here at the contact surface is always proportional to the normal reaction that is acting on the body here. And this is called as the limiting friction. This is called as the maximum limiting friction. Okay, or the limiting friction is nothing but maximum frictional force the body can offer, the surface can offer here, right? And if you remove the constant of proportionality, I can write this value as F is equal to mu into N. This is the value here. F is equal to mu into N is the maximum frictional resistance, and mu stands for coefficient of static friction or limiting friction, whatever it may be. N is nothing but normal reaction here. Okay, this is the very important thing. Friction was always proportional to normal reaction here. And we can write the value of N is equal to, if you go for sigma Fy is equal to 0, you balance the force in the equilibrium. And I can say this one as F is always equal to mu into W here. This is the important relation we can get. Okay. And I want to go for the concept of the friction. We are in the concept of friction. Okay. It is okay. Now I want to discuss regarding a point which is called as angle of friction. The very important angle. Okay, so I will be representing the angle of friction with the symbol of phi. Right? So how we can represent the angle of friction here? Okay, now see here. I am just drawing the diagram for you. Representation of force I am applying here. Now, so for example, if it is the Cartesian coordinate system, I can take this one as the plus x axis, plus y axis, and then minus phi, and there's nothing but minus x I can say. You can see what is the P applying here. P is acting towards the positive x direction, and F is acting in the negative x direction. And what about this one? Normal reaction is acting in the upward direction here, and the weight is acting in the downward direction here. Now you can see, due to the action of W, N is developed. Due to the action of P, F is developed. If there is W, no N will be developed here. If there is no P, there is no force F, right? So remember. Now, are external force acting on the body. Now W is the external force, N is the internal force developed, I can say. And if you observe carefully, P is the external force acting on the body, F is the internal force developed inside the body. So therefore, these two are called as the external forces, these two are called as the developed forces or induced forces. So what are the developed forces here? I will be writing these are called as developed forces, nothing but N and then F. Now for these two developed forces, I will determine the resultant force, nothing but the value R. Okay, and this, let us assume that resultant force is making some angle phi with the vertical axis or the vertical y axis. This phi is called as the angle of friction. Okay, the angle that is made by the resultant of F and N with the normal N is called as the angle of friction. And if I complete this right angle triangle, I can write the small relationship for the tan phi here. I will reveal this line here once again. Okay, therefore I can write the value of tan phi. So I can write the value of tan phi is equal to, what is the opposite side we have? You can say this side is equal to this side, therefore I can write this value as F also because parallel sides here. Okay, the magnitude is equal to F I can say. So F divided by, so what is the value? Adjacent side is nothing but the value N. This side is represented by the value of N here. Therefore, I can write the value of tan into, nothing but tan phi is equal to always F by N, which is equal to, what is the value of F? See from this relation, I can write F by N is always equal to mu, I can say. Therefore I can write this value F1 is equal to mu. So in the overall way, I can write this value as mu is always equal to tan phi, I can say. This is called as the coefficient of friction, is equal to tan of the angle of friction, I can say. Okay. So this is a very important relation. In the examination, generally the coefficient of friction will be given to you. If the coefficient of friction is not given to you, angle of friction will be given to you. For example, angle of friction will be equal to 15 degrees, 20 degrees, like that. Okay, so you have to substitute the value of tan 15. Then you can get the value of mu is equal to some 0.1, 0.2 you can get. Okay, so if mu is given to you, directly you can substitute the value of mu. If phi is given, you substitute the value of phi here, right? So therefore, this is the concept of this interaction for the friction here. And we have to go for different applications of friction and all those things. Okay, so please note on this one. This is very important point here. Mu is equal to tan phi and F by N is equal to mu. These are the very important relations we have. So 1 and then 2 it is, right? So how we can define the angle of friction? Angle of friction is the angle between the resultant of frictional force in the normal reaction and the normal reaction. I can say as phi here. Okay. Now let us go for a small problem. Okay. A 400 newtons block is resting on a rough horizontal surface for which the coefficient of friction mu is equal to 0.4. Determine the force required to cause the motion to impend if applied to the block horizontally. And the second thing is downward at 30 degrees to the horizontal. Okay. So no figure is given to you, just I will draw the figure for you. So weight of the block is given as 400 newtons. So it is the weight of the block which is equal to 400 newtons. Is resting on the horizontal surface, rough horizontal surface he was saying. So actually we have done all the problems till now by assuming the surface are frictionless. Now we have to include the friction at all the contact surfaces. And it is given that the coefficient of friction is always equal to mu is equal to 0.4, it is given. Determine the force P required to cause the motion to impend if applied to the block horizontally. Now what I am doing is, I am applying a force P here. Okay, in the first case. So what is the force that is required to move the block if it is applied in the horizontal direction? And the second case is if it is applied in the downward at 30 degrees to the horizontal here. I am taking the same block here resting on the inclined plane, sorry, on the horizontal plane here. Now what I am doing is, I am applying the force in the downward direction such that it is making an angle of 30 degrees with the horizontal. So what is the force P that is required here? So what is the force P that is required in this case, and what is the force P that is required in this case here? So in the gate examination, definitely we will be getting a problem from friction. So I will be solving the question papers after completion of this, all these things, right? Now, what is the force that is required to move the board in the horizontal direction? What is the force that is required to move the board in the inclined direction? That is inclined force we are applying here. Simple, all the things are practical applications. So to determine the value of P, first of all draw the Freebody diagram for this body here. Freebody diagram is nothing but it is a diagram which represents all the internal and external force acting on the body. Okay, so Freebody diagram is a diagram which is obtained by removing all the supports, and if you include some force, it comes under the Freebody diagram here. So I am taking the body here. Okay, and I am just representing the block here. So a force is acting P here. So you will be getting frictional force acting opposite the impending motion, and it's nothing but normal reaction is nothing but the weight of the body acting in the vertical downward direction. I want to discuss a very important point here. How we can solve this problem? I can solve this problem by writing the equations of equilibrium. So, do you agree that, or will you agree that this body is in the equilibrium? Okay, yes, this body is said to be in the equilibrium because you may have a doubt. So, actually we are applying a force P. Due to the application of the force, this body starts moving, or this body will be in the motion. Okay, whenever the body starts moving, or whenever the body is moving with some velocity, definitely the body cannot be in the equilibrium. But in the friction we will be discussing regarding the force that is required to just move the block, but not to move the block with some velocity or acceleration. Okay, therefore we can consider this body in the equilibrium. That is very, very important point here. Actually, due to the application of the force, the body may start moving. But when the body starts moving, the body may not be in the equilibrium. But what we are discussing is, in the question you can see here, determine the force required to cause motion to impend. Okay, that it is not something like a force that is required to bring a velocity of 10 meters per second or bring an acceleration of 25 meters per second. It is not the way here. Okay, so it is the force that is required to provide the impending motion is nothing but. Okay, now if there is no force, there is no force F here. Therefore, I can write the equations of equilibrium. Sigma Fx is equal to 0 and sigma Fy is equal to, right? And also we can apply sigma M is equal to 0 also if it is required here. So what we can say? So I can write this value as P minus F is equal to 0 and P will be always equal to F. So what is the value of F is equal to mu into N? So what is the value? Mu is equal to how much I can say? 0.4 multiplied by N I need. I need the value of N to determine the value of P. But if you go for summation of force in the y direction, I can write the value as N minus W is equal to 0 and I can write N is equal to W here. Therefore, what is the value of N is nothing but weight is given. So weight is always equal to 400 newtons. It is a very simple problem. Sometimes the simple problems may be given in the gate examination. Therefore, I can say this one as 0.4 into 400 is the value here. Therefore, I can say this one as 160 newtons is the value. Right? That is the thing. Okay. Now, we are applying the force in the inclined direction here. So, what is the force that is required to move the block here? I want to determine. So, to draw the free body diagram, you can understand everything. So, I am going for the free body diagram. Okay, first of all, draw the free body diagram, then you go for the Cartesian coordinate system here. The first thing is P, normal reaction. So, weight, frictional force will be always acting. And one more important point is frictional force is always a tangential force. Tangential in the sense, always the frictional force will be always acting along the surface of contact. So, this is the surface of contact here. Friction force will be always acting along the surface of contact only. It don't have any other contacts. It doesn't act any other directions here. So next thing is this is the force P that is acting at an angle of 30 degrees to the horizontal. Okay. So try to resolve the forces. This is the force P here. Now I am resolving in the Cartesian coordinate system. So P is making some angle 30 with what? With horizontal it is making here, right? Therefore can I represent this angle 30 here? Yes, I can represent. So this will be equal to P into cos 30 and this will be equal to P into sin 30, I can say. Okay. So what about the weight? Vertical downward direction. N is nothing but normal direction. Is nothing but the force that is acting in the opposite direction here. So I am writing sigma Fx equal to 0. The force along x direction. So the positive x and the negative x. Therefore, I can say this one as sigma Fx equal to 0. Nothing but P into cos 30 minus F is equal to 0. And I am writing sigma Fy is equal to 0 here. It's nothing but, P into sin 30. So, minus W, minus P sin 30 minus W. Okay. And we have a force of plus N is equal to 0. So, why we are getting normal reaction in this? We have force that is acting. There is restriction downward direction. As I told, normal reaction always acts in the restriction, opposite to the restriction motion. The body cannot move down. Therefore, opposite to the restriction, we are providing the reaction force. Normal reaction force acting always in upward direction, right? So, therefore, I can write this value as, so F is equal from this relation. I can write F is always equal to F is always equal to P into cos 30, I can say, and I can write this value as, see here, F is nothing but mu into N, which is equal to P into cos 30. Now how we can determine the value of N? Yes, I can determine from this value, in this equation. N is equal from this relation. So W plus P into sin 30 is the value here. So what is the value of weight we can have? Weight is always equal to 400 is given. So 400 plus we have determined the value of P. So therefore I am writing this value as P into sin 30. Okay. Now substitute the value of N in this equation. I am writing this equation here. So mu into N is always equal to P into cos theta. And here I can write, you can do one thing. You can cancel the terms here. See, I can write this one as N minus 400 is equal to P into sin theta, I can write. Okay. Actually here we have two number of unknowns. Okay. Two equations. Okay. Well and good, we can do that. So what is the value of mu stands for? Mu is equal to how much it is given? 0.4 it is given, right? Is the value of mu. If you divide these two equations, the PP will be cancelled. Then we will be getting some value of cos theta or tan 30. And from these two equations, you can determine the value of N here. This is the way how we can reduce the unknowns here. So you can determine the value of N. After getting the value of N, substitute in any one of the equations. Any one of the equations, substitute the value and you can determine the value of P. So if you do that, the value of P is equal to, 240 newtons is the value. Right? And can you observe the difference between these two values here? So here the P is equal to 160 newtons. P. In this case, P is equal to 160 newtons. And in this case, P is equal to 240. So in which case we have to apply more amount of effort. In this case we have to apply, because we are applying the force in the inclined direction. If you apply the force in the inclined direction, what will happen? It will be compressed towards the body, towards the earth. It will be compressed here. Therefore, it always resists more amount of frictional force. It always try to give more amount of frictional force here, right? So it is opposing to motion. It is something like we are applying the force towards the restriction. Okay, there can be no free movement. Therefore, we have to apply more amount of force acting on the body here, right? So therefore, this is the case in which we can apply the force. This is the way how we can solve the problem from friction. Very simple topic. So we have to go for different applications, lateral problem and all those things. Okay. Now I want to go for one more problem. Something like, this one as pulling is easier than pushing. Pulling is easier than pushing. I want to prove this one for 2 minutes. Now see here. For example, I am taking a block. Now on this block, I am applying a force. In this way I am applying here, making some angle theta with the horizontal. Okay, and this is the force P here. Okay, and this is the surface, and I am taking the same block resting on the same surface, but I will be applying the pushing force here, making some angle, same angle theta here. That means we are applying the force away from the body. But here we are applying the force towards the body here. Therefore, this is nothing but the pushing force, I can say. And here I can say this one as the pulling force, right? Okay. Now try to draw the free body diagram. I am drawing the free body diagram directly on this body. So what will be generally happening? So the thing is, frictional force will always act in the opposite direction. Frictional force Okay, in the opposite direction. What about this one? Weight. Normal reaction always acts in the upward direction, is nothing but frictional force F here. And here we can write this body as, for this body, so weight acting downward, normal reaction acting upward, and frictional force. See, we are applying the body towards this direction. Frictional force will be acting in this direction here. And if you observe carefully, in both the directions, frictional force is acting in the same direction only. We are applying the force in this way. We are applying the force towards the body. Here we are applying the force away from the body, right? So the body moves in this direction, frictional force is acting in the opposite direction here. Now if you observe carefully, if you draw the Freebody diagram and if you write the equations here, I can go for the equilibrium equations. So frictional force F acting in the opposite direction, normal reaction N, so nothing but weight. So P is acting in this direction, making some angle theta. Therefore, I can write this value as P into cos theta minus F. Any more force we have? No. And next thing is, plus N minus P into sin theta minus W is equal to 0. These are the first two equations here I can write. And what about this one? I can say this value as, so minus F plus P into cos theta is equal to 0 I can say. And I can write this value as plus N minus W, and we can have this value as P into sin theta. Yes, sin theta is equal to 0 I can say here. Okay, now solve two equations and determine the value of P in this case, and solve these two equations and determine the value of P in this case here. So if you determine the two values of P, so this value and this value, definitely, so this value will be more than this value here. Definitely, you can determine, you can observe here. So P constant is equal to F, again P constant is F here, but in this case we'll be getting the value of P outside here. Because what I want to say is, so the force that is required to push an object is more, okay, or very high compared to the force that is required to pull an object here. If you want to pull an object in this way, we have to apply less amount of effort. If you want to push an object, we have to apply more amount of effort here. Therefore, since we can say that pulling is easier than pushing, okay, the effort required to pull an object is less than the effort required to push an object, okay. But we have to compare this relation between the bodies having same weight and the surface are same here. The same surface and weights we can apply here. So please note on this. I am going for the next problem. Okay. Right. I'm removing this one. Now I want to go for the problem for a block which is resting on an inclined plane. Okay. Now see here. A 500 newtons block shown in the figure is in contact with a 45 degrees inclined line. The coefficient of friction is equal to 0.25. Calculate the value of horizontal force P necessary to just start the block up the plane. Second case, determine the value of horizontal force P just to prevent the motion down the plane. It's very important problem, just you have to understand clearly. So actually I will draw the figure for you. We have an inclined plane. Okay, on this inclined plane we have a block. Okay, and the angle of inclination is given as 45 degrees, and the weight of the block is given as 500 newtons. Okay, and the coefficient of friction, the coefficient of friction for the block mu is equal to 0.25, I can say. Okay, the value of P. Compute the value of horizontal force P. Yes, now on this block I am applying a horizontal force P here. Okay, so what he was asking first case is determine the value of P, horizontal force P, just to start the block up the inclined plane. Okay, so I am just writing the condition. Okay, and the second case is just to prevent the motion downward. Right, now see here. For example, if there is no force P here, generally what happens? If there is no force P, generally what happens? I am just going to discuss for 2 minutes. I will just draw the same problem, same block, having the force P here. Right, now see, if there is no force P here, in this case I am taking, if there is no force P here, generally what happens? Due to the gravity force acting on the body, the block immediately comes down. Now what I want to do is, this block should not come down. What I want to do is, I want to move this block up the plane, or I want to create the impending motion in this block. I want to just give a jerk. I want to just move the block here. So if this duster here I am placing the block, I want to just move this duster here. That's all. Move this duster, not moving the body into the motion here. Just to move into the body, or to convert the state of rest to motion, I want to just apply the force here. So that is the force that is required here. So due to the application of the force, generally what happens, the frictional force will be always acting down the inclined plane. Okay, and the frictional force always acts along the contact surface. And if you draw the Freebody diagram, so weight of the body will be always acting in the vertical downward direction, and next thing is this becomes a normal reaction force, always acting perpendicular to the surface upon which the body is resting. Okay, so this becomes your normal reaction, and this becomes the weight that is acting on the body here. Okay, now see here, this is the condition. Now what about this one here? To prevent the downward motion. Okay, that means here we are not applying the force to move the body up the plane. Okay, for example, if there is no force P here, generally what happens? Due to the weight that is present inside the body will come down immediately. Okay, so it should not be happen. That means the body is coming from upward direction. So we are just preventing the movement of the body in the downward direction, that's all. The body is coming from top to bottom. The body is moving in this direction here. The body is moving in this direction here. So we are applying a sufficient amount of force to keep the body at rest. That means what is the direction of movement of the body? The body is trying to come down. Therefore, if it is the case, we will be applying the force in the opposite direction here. Since the body is coming down, I will apply the force in the opposite direction here. This is called as the frictional force. F it is. This is very important motion here. So this is the direction of motion I can indicate, and here this is the direction of motion I can indicate here. This direction of motion, this is the direction of motion here. So depending upon the direction of motion, we have to provide the frictional force, not direction of the actional force. Okay. So generally we are thinking that, see, this is the frictional force, this is the force that is acting on the body. Due to the application of the force, the body will be moving in the upward direction, and you can provide the frictional force downward. No, it becomes wrong. Okay, so you have to read the question. To prevent the downward motion, that means the body is coming in the downward direction. So to keep the body at rest and to stop the downward motion, we have to apply the force in the opposite direction. We have to just apply the force and we have to stop. That means you should not apply the force to move the body in the upward direction here. Okay, so this is the case. So try to understand all these things. So direction of motion downward, frictional force I am acting upward here. In the same way, this is opposite direction. So here, what becomes the normal direction here? So weight of the body always acts in the vertical downward direction, and it becomes the normal reaction, nothing but the value n. Okay. Now how we can draw the free body diagram? So I am just going to the representation of the forces. This is your inclined plane. This is the inclined plane here. Okay. And this is your normal reaction n. And this is the frictional force F here. And this is the weight that is acting in the vertically downward direction W. And this is the force acting in the horizontal direction. You can observe these angles here. Force P. Okay. Any more forces we have? No. So this I am just resolving the force along inclined and normal plane here, right? So therefore this is something like resolving the force along the inclined plane, but resolving the force along normal direction here. Therefore I want to resolve the forces here. If you observe carefully, so what is the angle made by W with the inclined plane I want to see? You can see this angle is equal to 90, and this will be equal to 90 minus theta. So you can see right angle triangle here, right? So 90, it is 45. Therefore this angle will be also equal to 45 degrees. Therefore the angle between weight and the inclined plane is equal to how much I can say? This angle is equal to 45 degrees I can say. Okay. So what is the angle made by P? Just extend this force P here. Can you determine this angle? Yes, this angle is equal to this angle here, right? Horizontal, inclined here. So this angle is equal to this angle, I can say place the same 45 degrees here. Therefore I am placing this 45 degrees here and I am going for the resolution. So what happens if you go for resolution here? So this will be equal to P into cos 45 degrees, and here I can get the value as P into sin 45 degrees. Okay. So what about this one? I can get this value as W into cos 45 degrees, and I can get this value as W into sin 45 degrees I can say. Right? Now I am applying the equations of equilibrium. I am writing sigma fx is equal to 0. The first equation of equilibrium I am applying here. So if the forces are acting in the x direction, what becomes the equation? So this is the x direction here. I am taking this value as minus W into cos 45 minus F. So plus P into cos 45 degrees is equal to 0. And what about sigma Fy is equal to 0 here? Sigma Fy is equal to 0 is nothing but n. Next minus P into sin 45 degrees minus W into sin 45. These are called as the equations of equilibrium. Okay. So if you solve these two equations, you can determine the value of P outside. So how we can determine? Here F is there now. You can write this value of F is equal to mu into n. Okay. Here we have the value of n here. So bring the value of n and substitute the value of n in this equation. So if you simplify, you can determine the value of P. In the same way, I can write the equation for this one also. I am writing the equilibrium diagram here. So normal reaction always acts in the vertical upward direction. So weight of the body, friction force in this direction. So what about P? P is acting in this direction here, right? So what is the angle made by P? It's nothing but 45 degrees. So the main difference between these two cases is nothing but F is acting down the plane, the F is acting up the inclined plane here. Okay. So what about N? Okay, everything is okay. P, F, N and W. Now I want to resolve the force W also. The angle made by W is equal to 45 degrees I can say. And I can write this value as W into cos 45 degrees. Therefore, we have resolved into these components only. W into sin 45 degrees. Because see here, W is acting in this region. Okay. The total angle is equal to 90. Therefore, in this coordinate, along these axes only we can resolve here. So what about the remaining things? This is nothing but the value W here. So this is equal to P into cos 45 degrees. And this is equal to P into sin 45 degrees I can say. So these are the terms I can have. Therefore, I want to represent the equations here. So the first equation I am writing sigma fx is equal to 0. So minus W into cos 45 degrees plus F plus P into cos 45 degrees is equal to 0. And I can write plus N minus P into sine 45 degrees. So minus W into sine 45 degrees is equal to 0. So if you solve these equations, if you solve these two number of equations, you can get some other value of P. Okay. So I am writing the values for you. Okay, I don't have the values, don't worry about that. So these are the things here. So in this, if you solve these two equations, you can determine the value of P here. So P is equal to how much? This is one equation, right? So try to solve the equation, you can get the values of P. And if you observe the value of P, definitely I can say that this value of P is greater than this value of P. So here what we are doing is we are just moving the object in the upward direction. But this is nothing but we are just stopping the body which is coming from upward. We are just stopping the body. We are just keeping the force in this way, that's all. Okay. Therefore, definitely if it is P1, if it is P2, definitely the value of P1 will be greater than P2 here. That's all. So please note down this one. Okay. So this is the way how we can determine the equations of equilibrium. By unknowns from the equations of equilibrium we can determine here. I'm removing this one. So we continue after 2 minutes. Thank you.